So I finally finished the wellhouse filter setup. I just wrapped up the last few details. I have that spigot on the outside, you may remember. Brought this to 1/2 inch, 3/4 down to there. I decided to keep it 3/4 for a little bit of the way because it would freeze a little bit less readily. I'm not too worried about it, but I just figured why not. That and I was using up a little bit of extra 3/4. This is this fancy new peristaltic pump here, which basically works like an IV or something like that at a hospital. I'm trying to think about what people would typically see this sort of application with. It's a chemical pump and basically just pulls in chlorine, bleach water. Well, I diluted it because even on the very lowest setting with the concentrated bleach, it was just way too much. It must have been, I don't even know, 5 parts per million, maybe higher. Yeah, it was really crazy. So I diluted this significantly at 4:1, 4 parts water, 1 part bleach. And it's not something that we use regularly. We don't need to. There are a few advantages. You can chelate metal out of it, particularly iron in this case. And another thing I use it for periodically is shocking all of the plumbing. So basically just chlorinating all of it temporarily, leaving it in there for about 30 minutes or so, and then turning off the chlorination and just running water through it to clear it out. So it's something I used in this case when I was moving this filter setup, because the water between the well before to the house was full of turbidity and sediment and such. So because the filtration was only going on in the house, so all the line up to that was pretty gross. So a few other changes from my existing setup. This is actually a 1-inch line here, so I kept 1 inch throughout the entire filtration process. I added some unions, new valve. The old valve had obviously some pretty severe UV damage, just broken to pieces when I tried to even close it. So there was really no way to even try to close the valve. It was so old. Not a huge fan of PVC, but for keeping this at 1 inch and then tying into all this other stuff that was designed for the PVC, it just seemed a lot easier. So, and yeah, it's pretty messy. I wanted to get a shower in at the end of that day. After checking out some plumbing forums, T+2 and Teflon tape put together are a really sure way to not have a leak when using threaded PVC and such. So I'll explain what's going on a little bit. This union going to the pressure tank. This is the wellhead itself. And there's my main shutoff. Goes up. Right here is a 5-micron filter. This gets rid of all of the large sediment, and the water from this well is particularly turbid. So why is turbidity an issue? Because bacteria and such can hide in the particles because of the surface area, and that can protect them from things like chlorination. So I have a pre-filter here, and then I have my chlorination. Again, this is a new chlorination setup that I did here. Going over here, that's a check valve, so it's one way. And then I have 2 shutoffs around it for maintenance. So if I have to open up that corner bit there, I can close off those 2 valves. I have yet another union. And then this is called a Circus Tank. And basically what this does is keeps the water in contact with chlorine or other chemicals long enough for them to have an effect. Okay, moving on. I always hook it up this way because sometimes I would like to shock the lines, like I said. So right now this is going into a, if I recall correctly, this is a 0.2 micron filter here. So a secondary filter. And why would you need that? A couple reasons. Primarily chelation of metals, though. So all the iron trioxide and such in there chelates into a physical form instead of an ionized form dissolved. and then you particle filter it out. And then right here, I have a charcoal filter. It's actually a little bit more complicated than that. It's something like a zinc something, I can't remember. This has a few phases within it though. It's a pretty fancy filter. And I got this from Vitasalis. It's the Pure Master V750. I had this recommended by a friend. I've been using this for years and years. As you can see, I have a few tanks from Vitasalis. And I can explain a little bit more about what I do and do not use and why. Anyway, back to this valve setup here. Basically, I can turn this valve off, turn this one on, bypass removing the chlorine, which is what the charcoal will do, and then go straight through the output. I also have a water meter here. In the past, I hooked this up. It has a reed switch, a magnetic reed switch, so I think it's something like 1.58 gallons is one click. I just finished insulating all of these pipes for a few reasons. One of those reasons is that it will help prevent UV exposure, which will keep the plastic durable and keep it from bursting, hopefully. Another reason is if there's no power and maybe if the gables are open or something like that, this will just buy some time before anything freezes. And another reason is it helps reduce sweating, although these tanks are quite sweaty. So I'm not about to wrap these tanks. I'm not too worried about the tanks freezing because there's such a large volume of water. So it will help act as thermal mass, essentially. Okay, so this is the final insulation. I decided to cover my meter. It was just sweating like crazy, and it's not that large an object. And the thermal mass is not that great either. It's not very high. So it could potentially freeze because it's so conductive. This is actually supposedly stainless steel. I just finished some earth moving to berm around the foundation. Now this building actually has no footings per recommendation of a environmental health specialist who said that I could do a slab, but you don't want to dig a hole around your well, which makes sense. So I probably moved about 12 loads of dirt from an area that I just backed up with my dirt scoop. Dirt scoops are not really designed for that, I don't think, but it works pretty well. I've moved a ton of dirt, literally, that way. So, I think I will officially call the well house completed. I painted the door and the gables kind of sky blue. I put a little grate right here to make sure no critters go through that pipe. Everything is looking pretty good, and I actually already had kind of a catastrophic leak. I had one of these unions I had over tightened and it split. And that's one of the main reasons for building this is if there is some kind of catastrophic leak, it's not going to damage the house. It's just going to pour out of here. And that's essentially what happened. I was worried about the grade difference right here, but when the water gets high enough, it just exits, and also it can exit through these cracks here. So it can escape either way. So at this point, I think it's done.
blocking these gables makes it about 20 degrees warmer in here than outside. So by my estimates, I will never actually have to heat this at all. I was feeling pretty optimistic about using a 60-watt light bulb to heat it, but so far I just don't need to. It's not necessary. So I'll kind of keep you posted on how this works out in the winter, but as far as I can tell, when you limit the air exchange to about 1%, and then on top of that you insulate the heck out of the walls. If I recall correctly, the walls are something like R34 equivalent, and the ceiling is, I think, R26. But the R value, it has some importance, but the main thing is reducing air exchange. That is definitely the primary concern when you're trying to keep heat energy inside of something, because air is the conductor that's transferring, well, probably the moisture in the air and, the actual molecules themselves, of course, but I think that it's primarily the transfer that's removing it through convection and moisture. So limiting that seems to do the trick. So I'm optimistic I'll never have to actually heat this. We'll find out. It occasionally gets down to something like 16 degrees or so, but if you added another 20 degrees onto 16, you're still not at freezing. And I think that the other reason for it is that there's so much thermal mass. So you're getting water out of the ground. This particular well is drilled down to I think 375 feet or something like that. It might even be more than that. So you're drawing water from deep in the earth where it's at 50, 55 degrees. It comes up through these pipes, and then you have these thermal mass units here. You have the pressure tank, and you have a surface tank, and you have this charcoal filter here, and then of course these two filters. So overall, I actually think, especially with this wrapping here as well, that it will probably maintain enough of its heat energy from the earth, and then you limit the actual exchange of energy from it in terms of conduction. I think this might be fine.